Thank you. Thank you, Jim. Thank you for the opportunity. Let me share my screen. Okay, I'm going to see if I can put this on slideshow. Let me know if you are seeing this all right.
Yep, it says nice and big. It says build autonomous agentic AI apps on GCP.
Perfect. So the title says all about our presentation today. So we are in the agentic AI era, and enterprise adoption of agentic AI solutions are accelerating at a rapid pace. So from the time that we announced this session to where we are today, delivering the session, there are so many changes that have happened, so many capabilities that came out, and we have so many startups that are bringing agentic solutions to the market, and we are seeing um, the tools are changing as well from a developer's perspective. And now you have multitude of choices. When developers used to build these agentic AI solutions, it is always very difficult to see, like, what should I pick? What should I use? And if I am with a particular cloud vendor, how do I use their tools? And how do I use integrated systems? And how do I reduce the time to build and reduce the time to deploy? So with that, I'm going to start with the premise that developers and builders, you have exposure to a variety of tools, frameworks, techniques, models, and and you know how to choose from it. And today I'm going to show what you could do with GCP, what you could do in Google Cloud, how you prototype, and how you take it to production. So, given the audiences, I am keeping my presentation in the middle. It's not too technical or it's not too low level conceptual. So you can see how to build something from a prototype and take it all the way to production. With that intro, I'm going to start with some basic definitions of what these things are. Okay, so agents. So agents are autonomous systems that use models and external tools to reason and accomplish a task. So if you look at multi-agent frameworks will plan, combine multiple agents, orchestrate, select the right tool, models, etc., etc., and um, multi-agent systems or computational systems composed of multiple autonomous agents that interact to achieve a common goal. They can handle complex and dynamic process by segmenting them into discrete tasks that multiple specialized agents collaboratively execute. So it represents a move towards autonomous software systems beyond determinism and LLM prompting. So why do we have to talk about all these three? If you look at enterprise applications today, you might be using Salesforce.com, you might be using Oracle Business Suite, you might be using the human capital management system. You use a lot of enterprise apps. So if you see what is happening today, you would see in 2025 every one of them have some kind of AI assistance uh, embedded into their software. So ServiceNow has agents, Salesforce has agents. So everyone is moving towards that approach. Now you're going to see task-specific agents with domain knowledge getting added more and more. So this is where they're entering into the multi-agent framework. They're going to give you much more rich capabilities in every domain of the software that they have, and you're going to basically bring all these agents together collaboratively to do something, right? And then we are moving towards a collaborative ecosystem of agents that will come together and handle dynamic and changing scenarios. So that's where the multi-agent system comes in. So this space is growing pretty rapidly, and you're seeing a paradigm shift where we move from human-led manual process to AI orchestrated, autonomous, continuously adaptive systems becoming the new normal. So what do you do with this paradigm? As developers, you will be guiding, overseeing, and validating the work of intelligent agents versus building them, managing them, operating these applications and systems. So, what does a typical builder's journey look like? So there are three stages here. So you start with the POC, and then you prototype something, you like it, and then you go to a MVP stage. You build your MVP product, and then you got to take it to production. So if you look at your POC, so what I see in the field every time, everyone does a lot of POCs. There is so much money spent on these POCs. Some of the best practices to remember when you build this, when you talk about a POC, make sure you are having a proof of value. So define a use case that is narrow and it solves a real problem. Have clear success metrics and how you're going to measure them, and then start with the simplest architecture possible and the UX to address the core user outcome. So, having said that, if you show value for your business case, then you will get your funding, then you can move to the next stage. You can come out with some kind of an MVP. Now, when you are doing your MVP, make sure you at least build one entire end-to-end critical user journey and test it with the users. Now, that'll help you to iterate on the prompts, and that'll help you to adjust your architecture, evaluate your design, and you can evaluate the outcomes, and you can implement some feedback and metrics collection mechanisms. Once you have all that, so you have one end-to-end user journey, and then how do you take it to prod? Make sure you think about observability and tracing. Do your load testing and safety evaluations, and think about CI/CD. How do you do CI/CD, and how do you do continuous monitoring and evaluation, and of course, incident management. And then think about systematic collection of data for prompt improvement and or fine tuning. So we have seen what agents are. We have seen a multi-agent framework, and we have seen multi-agent systems and how they are defined, and what a typical builder's journey is. It is time to explore the builder's journey. During this process, I will highlight the Google Cloud tools, platforms, products, frameworks, process, and practices. So I'm going to start with a simple use case so that we can follow along as to how to build and how to deploy. So let us build a customer support refund system. So at Krabby Staffy, assume you are a full stack developer and you are at Krabby Staffy, a popular candy company. Right now, the customer refund system is handled entirely via email by two customer service reps. And as a result, sometimes it takes days for a customer to hear back about their refund. So what you want to do, you want to transform the refund systems using AI agents to, number one, boost customer satisfaction, send the refund immediately instead of days. And then number two, free up the two customer service reps so that they can focus on some complex tasks like handling requests for wedding favors or whatnot. So with that setup, let us go and see what do we want to. Our first stage as a builder is prototyping. So what do you use to prototype? Now the prototyping with Google AI Studio is amazing. We just released last week um, a way to do. Give me a minute. Let me bring my. I'm going to share. See if you see this tab.
Yeah, Google
Are,
AI
are you able to
Studio.
see the Google AI Studio?
Yep.
So last week we did our vibe coding. So you could do vibe coding, Gen AI enabled apps. You could build with it, and then you could chat with models in the playground, and we have a monitor usage and more in the dashboard. So we will come back to this Google AI Studio. Let me talk about what it is. Now, it is a browser-based integrated development environment for prototyping with generative models testing the input and the output. It'll quickly let you try out the models and experiment with different prompts. When you build something you are happy with, you can export it to your preferred programming language and use Google Gemini API with it. And you could also export this to Vertex AI which is our unified platform for building Gen AI and predictive AI solutions. Now, what can you achieve with this? You can generate creative content and innovative solutions. You can get deeper insights from your data. And of course, you could build cutting edge AI applications. Now, we have our use case. So what I wanted to do here is I wanted to quickly pick our use case and I want to put it into this prototyping tool. And I want to see um, if it can build a prototype for us. Okay. So I am sharing this tab.
Yep, I can see it.
Hopefully,
Yeah, I can
so I'm
see
going to
that.
go into my build. This is where you describe your idea, and then you can pick your models here, and then it also has a little mic there. You could basically input your idea through voice as well, right? And then here's all the stuff that you could do. Here are some samples. You can pick any one of them and uncover what is underneath it, right? So I am just giving a prompt. You are a customer support agent for Krabby Taffy. Your primary task is this. So what I'm saying is, please include a UI UX for extending the solution as a self-service application to the user. And I'm saying build a multi-agent system for this application with 4 agents. Now, I don't know how many agents I need. I'm just giving an arbitrary number because we want to build a multi-agent system. I'm just saying go and build this. And I'm saying use multiple patterns and control flow. And then I just want to showcase the power of the multi-agent system, right? So I'm going to hit the build. And there it goes to work. You see the code assistant here. You can set this code assistant up. And you can see that it is 2.5 Pro. And it is basically thinking. It is going to here's the thinking. So I'm just going to let it run for like a couple of seconds, and it's pretty fast. Our use case is pretty simple, so it is going to come out with code, and it's going to show us a preview. Okay. While this is building, what you want to think about is this is a quick way to build a prototype to see if your use case is pretty valuable and how you could prove out your use case um, with your business users and with your business and get some funding for it, right? You can do a lot of experimentation with this. You can play with a variety of UI, UX models. And then if you are a Figma user from your enterprise, then you could bring your Figma designs and you could import it to this. And you can see how all this works out, okay? Now, there you go. We have our preview for the application. Now we have built a AI-powered refund assistant. And then here are the sample emails. Um, so the taffy arrived all melted. I would like a refund. You know, it's a sticky solution, right? It's a sticky situation. Please help, right? So Bob is sending an email. So this comes into our system. It picks it up. The agent basically kicks off the workflow, and then it'll analyze the request, and it'll basically check for eligibility. We have the second agent. We asked for 4 agents, so it gave us 4 agents. And then it's going to propose a solution, and then it's going to compose an email, right? So let us see how this works out. Bob called and basically said, hey, it all arrived melted. Please give me a refund, okay? So you run the workflow agent, and you see that request analyzer is doing its magic, right? It's a bad sentiment, it's saying negative sentiment, and then it is verifying the eligibility. Yes, it is eligible. It is within the 30-day return policy, and then it checked the policy, right? And then you see that solution is proposed, customer is eligible for the refund, and then here's the email composed, right? We are sorry to hear that your taffy is ordered, so you just send this email. So this is how quick it is, right? So it gives you a bunch of options here. If you see the AI features, right? I can say, add store correct details, right? And then it says like enhance this, and you go back to work and you add that feature. So you can keep on playing with this, keep on prototyping with this. This is a very good way to see like how you are um, evolving your system and how you want to get to your MVP. Okay. Now, here are the changes. It is doing a little bit time. Give it a little bit more time, and then we will. There you go. So this time I want to do sample 2. Let us run this agent.
Say, Bala, while that one is running, Sanjay has a question on, in this part of the system that we're in, can we control token consumption somehow?
Yes, you can. Right. So the Google AI Studio, if you look at it, okay, it came back up, right? So I'm going to, maybe I'll leave this here and I will start another one.
Sure.
It is easy to show. So you can get an API key here for your prototyping. So here's your get API key. You can get an API key. This is all the projects. It'll show your usage and billing, and you can do all that stuff here, right? So it'll tell you what your rate limit is, and what your input tokens are, what your requests are, and then you could figure out, right? Now, having said that, Google AI Studio is free for you to use. You are charged for the API, right?
Okay.
So yes, there is a token limit, and yeah, it'll cost you. That is why we said, like, any POC that you do, you got to prove the value of what you're doing and prove the use case. Otherwise, you might end up with a very large bill that you don't know how it happened, right? So does that answer your question? And you can control it. I mean, it's there's a limit here, and you can control what services and how you use it.
Yeah, I think that covers it. You can
Okay.
flip back to what you're working on.
Now we have seen our here's the function added, and then it suggests a lot of other features that you could add. Now I'm going to leave it with you. Take this prompt and just go and play with it. I will share the prompt as part of the materials. Now I'm going to go back to the presentation, and now you have done a prototype. So the idea is, like, you do 60%, 70% of your coding, and then you bring back something that you can go to the next stage with. Okay. So now you have prototyped. There are a number of ways. There are a lot of ways to build an agent. Okay. So different control flows, different number of agents. What is important here is you got to understand the choices, the trade-offs, and what it takes to build in terms of resources and cost, right? So you can have a LLM agent, a single LLM agent. The agent relies on LLM to reason its way through the task, and then trusting it to call the right tools when needed, and then you could have this pattern, right? You could have a sequential agent where the agent has a hard-coded workflow that will call a sub-agent, and the order is fixed here. So you don't have that much flexibility when it comes to defining your pipeline and defining the order of execution, right? Then you can go with a single agent system, one agent with system prompts, set of tools, and a model. This is simple. It gives you a little bit control, and then you can go to a multi-agent system where you have system of experts with their own goals, system prompts, models, and tools. Here, you're seeing the highest modularity, highest flexibility that you could get, and the highest control that you could get. So you can pick based on what your requirement is. You have to think about what your ADLC, the agent development lifecycle, would be, and then you got to think through how you would take the system to production. I would say simplicity is you got to keep simplicity in mind. You don't want to build a very complex system that is very hard to manage and take to production. For some reason, my presentation is too.
Isn't
It is.
You said go to production with a simple system.
Yeah.
Isn't a complex system? Isn't that job security?
Yeah, it is.
I'm just kidding.
At least start with your simple system so that you can understand, what levers you're going to put in, right? Now, Google Cloud offers various levels of abstraction when building the agents um, and when building your multi-agent systems. You can choose the level of control, the complexity that'll best suit you. The levels range from building agents from scratch to using pre-built frameworks to no-code solution, right? So do it yourself. That is your level 0. This is the lowest level of abstraction, probably the highest flexibility that you could get. You can work directly with core components like function calling and Gemini, building agent code from scratch, potentially using an open source Python framework. The approach gives you full control over the entire process. Okay, so you see that the gray boxes there, vendor specific, it's RESTful, right? So it gives you a little bit of how you use it. There's an example shown with OpenAI, right? And then you have your level 1, which is your low-level LLM framework. Now, this provides the basic abstraction for common language processing tasks, such as parsers, splitters, prompt templates. You can use a framework like LangChain. Um, the caveat here is you got to learn the language, right? You got to learn the language for LangChain. And there's an example that is shown. You have a chain, you have a prompt and a model. You just chain it together, and then there is how you define your prompt, your chain, and how you send your requests, right? How you send your request and how you invoke it. And then you have the level 2, which is your low-level orchestration framework. This offers a greater abstraction around working with LLMs, focusing on orchestration logic. You use frameworks like LangGraph to build agentic workflows. Now we are stepping up one level higher, so this is agentic workflows. So you can create a workflow, and then you can kind of give every node of the workflow, and then have a tool called in every one of these nodes, and you could accomplish your task, right? And then you have your agent framework. This is a higher level abstraction, providing a framework like the ADK or the OpenAI agent SDK. So these frameworks are designed to simplify the process of building and customizing agents, offering a more user-friendly approach, right? So you can define your agents, you can um, define your tools, you can define the protocols that you want to use, and then you can bring it all together, and you can have a runner run what you build out of this kit, right? So with that said, above all this is a no-code platform, right? So Google has Gemini Enterprise that we released in the last 3 weeks. Um, it is a no-code solution. You can just go in and visually you can build an agent. And you can just um, drag and drop and build your agent, and you can bring in multiple agents. You can collaborate with them, and then you can just deploy it and take it to production. So that is your highest level of abstraction, where users can build agents with a rich UI without needing to code. Now you have all these options. Now for building this MVP, because I want to showcase the ADK tool, I'm going to pick the ADK tool. So ADK is open source. It will empower developers like you to build production-ready agentic AI applications with greater flexibility and precise control. Now, a couple of things to note about ADK. It is model agnostic and deployment agnostic. What that means is that you can use any kind of model you want. You don't have to just stick with Gemini. And then you can put it on any platform you want, any hyperscaler you want. This is an ideal development kit, getting a lot of traction in the field. A lot of people are using it now to build and deploy their multi-agent systems. So with that, we are picking the ADK. So let me. So what do you have in the ADK? So what do you get when you use the ADK, right? You are going to get all the stuff that you see there, right? It's a client-side SDK to define multi-agent applications for complex real-world scenarios. So you can define your agents. You can define the tools the agents can use. You can define your orchestration. You can have callbacks. You can have bidirectional streaming, and you can have session management with it. You can have evaluation as part of it, and of course the deployment. And you have artifacts management. You have memory. long-term and short-term, and then you have code execution, and then you have way to influence the planning, right? And if you see what it comes with, it has it has models at the bottom, and you can trace whatever is happening in your agent, and then you can debug to any level that you want when you're building agents with ADK and running it with the ADK runner, right? So the ADK current version is 1.17. Then I checked October 2025. So there's a link. Go here. There's tons of content here. Play with it. You can start with Python. You can start with Java. Those are the two modes that we give you. So it is very easy to install. You just I just clicked on it. I just wanted to show you. Um, Here's your Python, here's your Java, and then it talks about a multi-agent architecture, and you can explore it. That's your documentation, right? And then if you look at the ADK samples, we have simplest to very complex samples. So you can come to this samples directory, and you can pick any one of these. There are a lot of agents here, and you can pick any one of these agents to see like how you can build your own agents, and then how you can reuse some of this code that is shown here. Okay, and then once you get here, now let us see how we can use this to build what we are building, um, our Krabby Taffy Store refund agent, right? So before we start our building, we have to look at some architecture patterns that we can use, and then some of the interaction models that we can use to design our refund agent. So let us dive into the architecture patterns. So this slide illustrates 4 fundamental architecture patterns for designing agentic systems. So you see the first one is the single. This is the simplest approach, using one large LLM to handle all tasks. In our case, we can use a single all-in-one LLM that handles the entire process from reading the email, checking the order history, calling the refund tool, and drafting the confirmation. The trade-off here is this is the least reliable for complex requests, and it's prone to errors, and it makes auditing and fine-tuning pretty difficult. So you look at the sequential pattern. So what this gives you, this pattern chains multiple specialized LLMs in a pipeline. So the output of one LLM becomes the input or the intermediate result for the next, allowing for a structured multi-step process. The request flows through specialized agents in a fixed order. An intake agent will extract the details, a validation agent will check the eligibility, and then an action agent will process the refund. What this gives you is this will provide a reliable step-by-step workflow with clear checkpoints for tracking and safety. So the trade-off here, this is less flexible for dynamic requests and may introduce latency because of multiple serial calls. The pattern that you have on the left-hand side bottom is the parallel pattern. This pattern uses multiple LLMs to concurrently process the requests, process the input requests. Their individual outputs are then combined by the aggregator to produce the final unified results. Right now, in this case, this pattern is often used for tasks where you could break down the task and you can execute it simultaneously. Right. In our case, we can have multiple agents work simultaneously. As soon as you get your request, one can check for the order eligibility, the other one can verify the customer identity, and then another one can start drafting a confirmation, and then the aggregator will collect everything and authorize the refund. Right. So in our case, we can use all these patterns, a combination of these. And if you look at the hierarchical pattern, this is the more complex one. This is a more complex to set up. It has a central router model that analyzes the input and directs it to the most appropriate specialized LLM for processing. Now, in our case, we can have a router agent analyze the incoming email, determine the complexity, and we can say simple request, yeah, send it to the standard refund agent. And then if it's pretty complex, it cannot be handled by the agents that you have, yeah, send it to a human, right? Um, let them pick this request and work with it, right? So in this case, the central router's decision logic is critical, and it will require rigorous, complex testing to prevent misrouting. So now we know the architectural patterns. We are going to use some of this for building our MVP. Now let us go and look at the interaction models, right? So there are two interaction models. So there's a
maybe a quick question, Bala. Well, it's from the chat.
Mhm.
From Rice. Maybe apologize if I pronounce your name wrong. But as far as the ADK, does the ADK now have built-in A to A support without the need for
Absolutely.
custom ADA implementation?
Absolutely, absolutely. Depending on the time, I have a couple of slides on A2A and a couple of slides on MCP. So these two are becoming pretty much standard in the industry, and Google also released the A2P, agent to payments protocol. So yes, all these protocols are supported, and it's very easy to define. And you would see that when you define the agents, you can create an agent card, which will be used for communication between agents, and then there is a flow, execution flow that you
All
could
right.
define.
Yeah, cool.
Okay. So coming back to our multi-agent interaction. So we have cooperative multi-agent system and we have competitive. Of course, the name says it all, right? So in case of cooperative, you have a coordinator and then you have so many agents working. Coordinator will know which one to call. It will understand the dependencies. It will then dispatch specialized sub agents, and then you know um, it'll take all the synthesizer will take all the output from this, and then it'll provide you the outcome, or it'll provide you the results, right? So in this, you have multiple LLM based agents collaborating to solve your problem, right? On the competitive side, this is a very interesting model, right? So independent LLM agents will propose competing solutions, and then you have an evaluator here. The evaluator is going to pick the best or integrating elements, right? So again, this system, when you look at the competitive system, it's a very robust, and it'll be ideal for policy compliant outcome, executing your final action. Um, so you basically have your final decision well tested out against different perspectives. So the trade-off with your competitive thing is that the model is slower, and then of course more expensive, and it might not be a good fit for our immediate goal of customer response, right? Um, with the um, with the cooperative model, the model is highly efficient, modular, and fast. But you got to remember, it requires complex orchestration to manage the flow and dependencies between the agents. So we have seen the models, we have seen the um, trade-offs. Now let us go to our design. So here's an example of how we want to design this, right? So we are going to do a multi-agent. We are going to have a custom flow for refunds, and we will pick this design to showcase the patterns, the flow, and the interaction model. Couple of things that you want to see here is that um, you have a Gemini 2.5 Flash model that we are using, and then we have the tools you can this is Python functions that we are using today, and it will go as part of the tools.py file in ADK. But you can extend this. You can use MCP. You can bring in your own tools. It is well integrated with the Google Cloud, so you can have any kind of tool called. Okay, so the toolbox, the database toolbox for MCP from Google will connect you to n number of databases that you can connect. So you can basically use a database for your purchase history, for your customer identification and whatnot, right? And then On the left hand side, you see that please give my refund. That is where it starts, and you have a base agent, and the base agent has a runner. It'll start a session. You see the session and the state, and then we are having a parallel verifier agent here. So the parallel verifier that you see is kind of the control flow, right? So we are using the parallel model here. So we're going to execute these two parallelly, and then it's we're going to see if it is eligible for a refund, and then we are going to call either the store credit agent or the refund processor agent, and then the store credit agent is going to call the process credit decision if they accepted what you proposed as a offer, alternative offer, right? And then it all comes to the final response agent, and then it gives you the output message, right? Now, there are so many ways to build this, and I'm going to share a repository where you would see that we're going to have 5 different patterns that we could use to accomplish the same thing. And I picked this to show whatever we talked about from an interaction model perspective, whatever we talked about from a architectural pattern perspective. Okay.
All right.
Now I want to do a quick time check. How much time do we have?
Maybe about 20 minutes. Is that enough time?
Um, I think yes, right? Let us see if we could show the ADK in that time, right? So some of the key things to consider, right? So here are the 7 things that are listed here when you are building multi-agent systems. And the first one is your memory and personalization, right? Consider how agents will manage the memory and personalize interactions to provide relevant and continuous experiences, right? So from a memory, you can have short-term memory, you can have long-term memory. Short-term memory is basically your session memory. You can have a long-term memory, which is a persistent memory. You could define your persistent memory, and you can store it in any data store. Then number 2 is your tool calling. So effective tool calling mechanisms are crucial for both agents to fetch necessary data and to execute actions necessary. The third one is prompt-first debugging. Facilitating a simple prompt-first iteration process is essential for you to easily inspect the thinking and debug streams during the agent development process. Right? So this is what you're going to use with the prompts.py file with your ADK, and you're going to test your prompts again and again in your prototype. You're going to see how it works out, and then you get to a prompt that is pretty acceptable for what you're trying to do, and then you bring that as a prompt, right? Number 4 is your agent evals. Comprehensive agent evaluations require tools for evaluating the plans, sophisticated tool calling, precise parameter construction, and often automated code generation. And then you have your dynamic planning and orchestration. Given the complexity of agentic workflows, meticulously plan for dynamic planning and orchestration during the serving process. Right? Then you have production tracing. Tracing dynamic execution path in production is critical for troubleshooting and understanding the real-time behavior of the workflows. And then think about the feedback loop. Implementing a robust feedback loop tools is vital for collecting performance samples and continuously improving your agent accuracy. Now, we have seen all the key aspects to consider when you're building the agents. Now it is time to go into ADK and look at our ADK. Okay. Now this is what our multi-agent custom control flow looks in the ADK. I just captured a snapshot so that you can see what is happening here, right? So when you log in, there are a couple of things that you would see, you should note, which is here's your session ID. So every time a request is created, a session is created. So if I hit a new session, it's going to create a new session, okay? And there's token streaming here, which is basically saying that, if I turn that on, you don't have to wait for the response. You can interact with the agent in a real-time fashion, right? And then on the left-hand side, you have a bunch of things there. We talked about events. I will show you how all this is run in ADK. So everything is an event. and then you have a state where you can see pick any running process and see what the state is, and then you have artifacts, and you have session details, and then you have evals, right? And then you can understand your flow. It can show you, from invocation, what is happening, what agent is running, and what function is running, what LLM is called, and you could follow that with your ADK, right? So I'm going to show you ADK web UI so that it's easy for us to follow. Of course, all the terminal junkies, you can use it in command line. Um, you can use Gemini CLI to basically call and build something for you, and you can test all your production deployments from your terminal as well. Now, I want to open up the code, and I want to show you our agent. And before we do that, I'm going to walk you through some of the basic things that you would see, and then I will go ahead and open it. Give me a minute. I'm going to switch to a tab, and I'm going to open the console, and I'm going to open the terminal. And once I open it, I will share it. Give me a minute. It's provisioning, asking for my authorization. Okay. All right, I'm going to share this tab. Hope you are seeing my terminal.
Yep.
So here's our code. Here's all the demos. And I'm going to go to our agent patterns demo. That's where all our agent patterns are. So this is a Python code. So I just did a pip install of the ADK, and then I just cloned the repository, and then I have all this. And I have 5 different scenarios that you could play with. You can clone this repository and then try out all these 5, and then you can understand some of the trade-offs that we talked about and see how it works when you are building these agents. Okay. Now, before I open up the editor and go through the code, I want to cover a little bit on the ADK as to what you're going to see, and then we will come back to this. Okay. Now, ADK agent base, this is where you define your base agent. So you have a name, you have a model, you have some instructions, you have tools, and then you have sub-agents. That's how you define it. So from the model's perspective, you can use any kind of model that you want. Don't have to stick with just Gemini, right? And then from an instruction set perspective, you're going to have a prompts file. You're going to see, you're going to clearly define what the goal of this agent is. You're going to give a description, and you're going to give clear instructions and a playbook so that this agent is more functional, accomplishing the goal. And then you have tools. As you all know, tools are tools, right? You have Google out-of-the-box tools that you could use, like the Google search. So whenever you want to ground an agent with Google search, you can. Or if you're building a system where you want to go and search for something on Google search, you could do that. And then you also have Vertex AI search, which is kind of a rag out of the box, right? Then you could have custom input and output, and you have video streaming, databases, files, signals, whatnot, right? And then the output is the same thing, right? And then you have agents, where you have the sub-agents. You define all the sub-agents that come with it. This is how you define the base, okay? And how does it look like in code? So this is how it will look like. From the ADK, you will import the agents, and you will import the tools, and then you will import your prompts, and then you pick your model. I picked Gemini 2.5 Flash Preview here, and then you have your agent definition, It basically says what the model is, it says what the name is, and then there's a description for it, and then you have a top level prompt that you're passing in as instructions, and then you have your tools, which is your get purchase history and check refund eligibility and process refund. These are basically Python classes. You just define your class and you just define your functions, and then you just call them as tools. And then you're initializing the root agent, and then this is how you will define this base agent and basically pass it to the runner to run. Okay. So the runner, right? So you create a runner and you basically run this thing asynchronously. Okay. So what happens in this case? The first block that you see there, the runner, it creates a runner instance. It configures the runner with the app name and an agent instance. And then you have the execution is the second block that you see there. So it calls the run async function, and then it's passing on the session ID, user ID, and the new message, which is the content as input. Okay. So that's how you use the runner. And then let me go to the, now we know how to run it. Now let us talk a little bit about the memory.
So, Bala, in order to use, do we have to use the ADK in order to use the runner? Is that kind of the idea? They need to go together?
The goal is the runner is how you invoke it, right? You can invoke it with Vertex AI. You can invoke it with a variety of stuff, right? This is just to check it out, to validate your MVP. But if you're doing a production run, you have a variety of options to deploy this application as a container. And then we will cover how we will deploy this in Google Cloud a little bit later slides. Okay.
All right.
So runner is how you basically, you develop something and you will run it with the runner. Okay. So when you use the ADK run command, it is going to call this runner and basically run this. Okay. So we talked about the base agent, the root agent, and all the sub agents that you defined. And then think a little bit about the memory. So on the top is the session memory that you see there. Now it is a short-term memory. And then you have events and state. Okay. So everything happens as an event, and the event actually kicks off the cycle, and then it calls the next appropriate thing. Might it be an agent, might it be LLM, and then it goes on all the way to execute. It comes back, and the state is stored as a key value pair. Okay. Now on the bottom is your long-term, short-term, your call. Basically, it says like you can do whatever you want here in terms of storing this memory. Now you take all these sessions and you can store it in memory, and you can store it in Vertex AI service like Vertex AI, or you can have your own database, a persistent database that you could store, right? So
if we can store it in our own database, that means the long term can be like really long?
Yes, however long you want it to be.
Okay.
Right. So it is basically saying that, on the session side, every time you kill a session and restart a session, there's a short-term memory associated with it, right?
Sure.
I can use the in-memory. So if I use the in-memory, it is all gone. It's wiped off, and I'll get a clean one, right? So if I store it somewhere, yeah, of course I can use it. I can have that short-term memory for the session as well as the long-term. Okay, depending on where you store and how you store and how you recall it. Okay. Okay, it's a little bit. So the runner and how the memory gets associated with it, right? So you have your base agent, you call the runner, and then the runner is going to post an event, right? And the event will basically, initiate the get session, and then it has a memory associated with it. and you're going to get a session ID. Okay, and then you invoke the agent, and then you kind of give a update for the session, right? So this is where your session state is stored, and then if the agent is invoking a tool, then another event is posted, and then you invoke the other tool, and it keeps on continuing. Okay. And then your workflows, we talked about all these workflows. Here we are going to use the parallel agent and LLM agent. We are not going to use the others. So you can define your workflows. It is basically, your definition of a parallel agent, and then all the things that the parallel agent would do, and how the logic will reside, and how it will basically come out with the output, right? And of course, we talked about the LLM agent. These are all independent agents. The LLM agent model, where it can call a number of sub agents as well, right? Here's how we are, just to show an example. This is how we are doing our parallel agent. We are calling it refund checks, and here's all the sub agents that it's going to call, and the sub agent list. You give a sub agent list. Okay. Now you can have callbacks. This is a pretty big topic by itself. So you can manage state. You can read dynamically, update the agent's session state. You can implement some guardrails with it. And then you can have some controls with the base agent. You can do caching. You can observe and debug. You can do notifications, right? So you can do, when you are defining your base agent, you could do before agent callback, and then you can do after agent callback. This is just stating in a simple sentence what it is, right? From a definition perspective. All right. And how it works, it is kind of a eye chart. But I want to quickly open. There's a link there. I want to quickly open this link, and I don't know if it is any better. I can. I'll not walk through the entire cycle, but it'll tell you what it is doing. Okay. So here's your user. They are sending a query, and then you have a runner, and the runner is loading the session. And then the session service is invoked. Might it be a Vertex AI? Might it be in memory or whatever it is, right? And then it returns your session ID. And then you add the user query events to the history. And then event added OK comes back as an acknowledgement. And then you prepare the invocation context. And then you run the agent asynchronously. And then it determines the need for the tool. And it'll go and do the tool. And then it comes back with a yield call. The yield is kind of a callback, right? And then it goes on. Okay, so that's how it gets, how a typical user query that involves the LLM agent flows. Okay. Now, let me go back to the presentation. Of course, there's a simplified version. That is what I opened with the link here. Go and play with it. I wanted to spend a few minutes on, somebody asked about the agent-to-agent protocol and the MCP.
Yeah.
I want to spend a little bit time here, just to say, when multiple agents come together, when multiple tools come together.
Did you flip back to something else? I still see the sequence diagram.
How about now?
There we go.
Okay. So when you look at the agent-to-agent protocol, we are getting into a world. When we started this conversation, we basically said all the enterprise systems that are available today in the market, they're all going to release agents. Okay, whether you like it or not, your job is going to basically, discover them, bring them together, make them talk with each other, and get the required output that you need. And as we said, we are getting into a world where we are going to collaborate with all these agents, and then all these agents by themselves are intelligent, they are autonomous. You got to control them, and you got to get the desired output that you want, right? So the role of the developer is changing, the role of the software engineer is changing, the role of the data analysts and data engineers are changing. And this is going to be more of guiding, more of using what you have, and how to bring all this together and how to collaborate with all these agents, right? So you see all the agents out there. Now, how do they talk to each other? That's where all your question marks is in between. That's where your agent-to-agent protocol comes in. So protocol is basically a set of behaviors that you implement, right? The agent by themselves, if you see the tool on the, the agent can call any tool. Now, if an agent wants to talk to a tool, you're going to use another protocol, right? So you're going to use the MCP protocol there. Okay, so this is where the agent to agent protocol fits in. Okay. Give me 1 minute. I think all right. Are you able to see the next one?
Yeah, 808
So-
agent card.
In the world of coming out with a lot of these agents, so what is going to happen is you're going to have a A2A agent card. Okay, so whenever you define an agent, you're going to have an agent card, which is going to say who the provider is. For example, we have Google URL here, right? So what is the preferred input and output? This just says text. You can have anything you want there. It's going to say what its capabilities are, and it's going to say what its skills are, and it's going to say how you authenticate to it. Okay, so every agent is going to have this agent card. Okay, so what this allows you to do is this allows you to do agent discovery. So all the agents cards are initialized and made available by the server. So you have the A2A server, and you have all the agents there. You have all the agent cards, and you have all the tasks, right? So you can interact with this server. You can get the agent card. You can get a task. You can send a task to execute. You look at the client discovery side. You discover all the available agents by retrieving and storing the agent cards in its list of available sub agents. Okay. So you have a workflow agent there, you have a model and an instruction, you have sub-agents. So you basically get these cards and you will store it in the list of available sub-agents, right? And then the agent selection based on the instructions processed by the LLM, the client will decide which agent to interact with. Now you have a planning, you have a reasoning, and then it's going to say, I'm going to use all these agents. Now, from a sub-agent perspective, you would see all these cards and say, like, what makes sense from an agent perspective, and you're going to basically call that agent. Okay. So what happens with the A2A task execution flow, right? So the task initiation is done by the client. It's a serialized JSON and sends a request, request. And then the task validation happens. It deserializes and validates the incoming task request. And then you have the task store, store the task ID, status, data, and the context for tracking and persistence. And then you have the task execution. Task execution is going to load and initialize the appropriate agent, executes it within the created context, perform the actions defined in the task request. And then you have the response, which serializes and sends a response containing the task status, and then results back to the client. So that's kind of your execution flow when you are using the A2A server. Now our model context protocol. So when your agent is calling a tool, typically you will have an MCP server, which will have a list of tools, and then you can call that tool. Okay, so you define this in your ADK. You will have a tools section where you define tools, and we call 3 tools. We said like these are Python functions that we wrote, and it is going to be in tools.py file, and that's how you call your tools. And once you have the tools in the tools.py, you can call it with a definition on the tool list, and you can say what the tools are, right? And you can have a MCP server, and the MCP server can have like a fast MCP that you could use, which has some 200 plus different tools that you could use. You can use the MCP toolkit for databases from Google. It allows you to connect to a number of databases, and then you're going to see every one of those enterprise software vendors providing you MCP servers and tools that you could use. Okay. Now, this is the protocol that you use when you have agent working with a tool. Okay. So the stdio is standard input output, and then you have the SSE. Give me a minute. I'm just playing with the slides here to see if I can share. Okay, I think this is it. Does it build up? Give me a minute. No, okay. So the way you communicate with, you have your agent, the MCP client, and you have a MCP server, you have a bunch of tools, and the mechanism that they communicate with each other is going to be the standard input-output. That's what they keep passing. And then you have the MCP client reaching out to a remote MCP server. In this case, you have the server sent events, and that event is picked up by the MCP server, and then it responds. Okay.
And a question from Sanjay: How does authentication work with ADK and MCP?
Now there is when you define, you can define your agent with authentication. In one of the sections when we define that parallel agent, you saw that there is an authentication part, right? So you can have your authentication mechanism defined there,
Okay.
right? And you can have a variety of authentication mechanisms to basically communicate with the tools. Okay, that is one of the critical areas. So when you are under the Google Cloud umbrella, you get all the security with it, and you're working in the boundaries of the Google Cloud inside a project, and then the authentication is very well defined. You can use your credentials and you can communicate with the tools, right?
All right.
Now we have come to a point where we have seen how we built it and what our A2A is and how we are calling the tools, what our NCP is. Now, I have a few more slides, but before that, I just wanted to quickly show the code, open the code and show the code so that when you get the repository link, you can log in and you can check out all this stuff, right? So I am going to go to my Cloud Shell. Okay. Are you able to see my? Yeah, let me bring up
a couple percents bigger.
Let me see how to do that. Let me. It is not helping me open up.
Does it work on like a control scroll wheel or anything like that, or the pinch move?
Let me go back and reopen this terminal. I'm not sharing the terminal yet, right?
No.
Okay.
And we'll try and work back through. There's some questions in the chat, and I'm queuing them up. There's more than I've asked, just to see if we get to the end here. Definitely a lot of things with ADK, A2A, multi-agents and all the patterns, and definitely a broad intro across that landscape.
Now it doesn't show where to share this tab. How do I share this tab? Okay. Did I get out of my share?
Yeah, you'll need to go to click on.
I'm not sharing anything?
Yeah. No, I'm not sharing. You're not sharing. Should be able to in the.
How did I lose my share? How about now? I'm sharing something,
just
right?
in production, they said.
Okay. Let me share this tab. And I'm going to make this bigger. Okay, I can make this guy bigger.
Does it work? It's just in a browser, right? Can you just
I am on the browser.
you
Let
just
me
do a
see
plus
if,
a few percentages on the browser? Yeah, it's definitely good. No, it's definitely really big now.
How about now? Better?
Yeah, that looks great.
Okay. So when you clone the repository, you're going to get a number of things with it under the AIML, and you're going to see agent patterns. These are the 5 patterns for you to play with, and this is all about the refunds that we were talking about. Okay, so when we and I'm going to see if I can open up my terminal from here.
All right. Yeah, looks definitely bigger.
Bigger?
Yeah, looks good compared
Okay.
to last time.
So the flow number 5 is what we did. Okay, custom agent control flow. That's what we did. All right. So when you start your ADK, you would just say ADK web. This is going to start our ADK.
And while it's starting, do you have the repo link at your fingertips?
There you go. It is. So wherever you start this ADK web from, it is going to go and search to see if there is an agent file. Okay. So if it finds agents, it can list all your agents there, and you are going to see this, then it comes up. Okay. Now I'm going to pick one of the agents. You have these 5 you can play with, but I'll pick the custom agent. Now I want to give it in the interest of time, I'm going to see if I can go and copy a prompt here. We saw that we had a bunch of names defined in our static library. I'm going to say so it is going to work. It is basically,
Well, the agent,
it's going to.
yeah. While the agent is thinking, do you have the link to the repository, or is the link
Yes, I
really
do.
shareable?
Yes, it is shareable, and I will post it. Okay. So I got to set up my. This is where you will need a API key.
Okay.
I hope I'm not sharing the API key.
No.
Okay.
It's just our faces.
I'm just. Did everything come out of the share?
Yeah, it's just me and you. No slides right now.
Oh man. Let's see.
All right, I can see test and production, they said. And I can see a console.
Okay. I'm picking an agent, and I have to go back to get my.
So we
prompt.
started the agent. It actually wasn't working because we didn't have the API key. Is that
Yes.
the idea?
So we have to put the API key, and then. So you can see it is working. It is getting the purchase history, and you could see the events. It is checking for refund eligibility, and he says like, hey, here's your purchase history, Alexis. Here's your order ID. And then the eligibility is checked true. And then it is processing the refund. It is calling the process refund agent, and it's processing the refund. And it says like, I'm sorry to hear that your order is damaged. I have processed your full refund, and here's your refund. should you see credit applied to in 2 days. Okay. So let us give it another prompt and so David is saying my order never arrived. Again, checking for refund. In this case, it is false. It basically says, do you want to accept a store credit offer, right? So then we will say, yes, we will get it.
So Carol said she did see your API key. I don't know. My eyes didn't catch it. So
did she see the key?
She said she saw a key. So you might want to delete that one once we're done here.
Yeah.
Not that I don't think she has photographic memory. But, actually, could you just destroy that key when we're done? That way I won't have to fuzz it out. I won't have to fuzz it out when it's recorded if you destroy it.
Absolutely. I will just destroy it.
Yeah. Rotate keys.
Okay, so you see events, state, artifacts, session, and eval on the left-hand side. So on the events, so we saw the flow, right? So a request comes in, you get a session ID, and then it starts the calls, right? So your event, everything is posted as an event, and a lot of things happen in the event, and then you see kind of what is happening from 0, 1 to 3, all these steps that happens. Okay, and then you could go to the trace. You could pick every one of those invocations. So every time that a runner runs, it is going to invoke, and it is going to show you what happens.
Do we need
and
to
how
see something more than just the console? So we've been watching that.
Oh,
sorry. The text go through.
How about now? See anything?
Yeah, now we can see the
okay. So you guys didn't see what happened here. So I put my name is Alexis. It ran all this, and then I gave a second thing. My order never arrived, and it basically said, it's going to give me a store credit, right? And then
it was coming through the logs. It just wasn't very pretty.
So I'm going to show the events. So we talked about the flow, right? When we had the ADK, request comes in, there is invocation that happens, you get a session ID, and then you see events, right? So here is all your events that are happening. And then you could trace what is happening with every invocation. And then if you go to your invocation, it is going to show you what is happening. Okay. And then it's on the right-hand side, you see how many milliseconds it took to basically address your call, right? And then you can check the state. So here's your state, your purchase history, and what is happening. This is the state that is being passed. And then you have your sessions. We have only one session here. So this is your session. And then you can have some evals. You can create a new evaluation set, and you can evaluate your service. Okay. So that is about the agent development kit. It's pretty simple. You can just give it a simple command like create agent, and it'll throw you 3 files. And let me see if my session here is still open with. Okay, I'm going to share this tab.
All right.
Now, if I look at one of these agents, so before I open up that agent, right? Is it big enough that you could see everything? So in the agent patterns directory, you see this agent.py, right? So this is the one. This is the base agent, okay? This is the one which defines all of these things. I just want to close this guy. Okay. You can look at the code here. It basically implements your base agent, right? And then you see the tools directory here. This is where you have your prompts and then your tools, okay? So for every one of these agents and sub-agents, we have defined the instructions. This is where the instructions go. This is a top-level prompt. And then you keep describing your instructions and what the agent's goal is, right? And then you have the tools.py. This is where you have all the tools. And in our case, I basically said we created a bunch of classes and we just define functions, and that's kind of a tool. Okay. And then if you go to every one of these agents, so you have an init.py. This basically, is going to you want to do all your imports here, and then every one of these agent.py is going to define what the agents are. In our case, if you look at this, this is defining a class. Here's all your agents. We are using a multiple LLM stuff, and then we are using a parallel agent. You go and define what the arguments are. You define how it is getting invoked. We are running a async implementation here. So this is where your invocation happens, right? So that is kind of it, right? So you can look at the code, you can connect it back to what it is, and then um, you could customize it, you could reuse it. You can see how every one of those patterns work and how every one of these flows work. Okay. All right.
Question from Pavan, not from Pavan, but from Partha. Is there a way to make any of these examples 100% deterministic?
Why would you want to do that?
I don't know. That's the question.
Yeah, it is. It is just your control flow, right? I mean, you can make it deterministic based on a rule. You can write a small Python program, and then you can make it deterministic, right?
Yeah.
The idea is to show you the agents and how to make a multi-agent system and how to make them autonomous, right? So I would rather think about how to make it non-deterministic rather than making it deterministic.
Then on the ADKs, how do ADKs handle external tool failures? So your agent is using MCP server to try and use a tool and it fails.
That brings back to my last topic here, right?
All right.
So
Okay.
I will address that question. I'm going to say you're going to deploy this on Google Cloud. That's what if you are deploying it on Google Cloud, of course you're going to use all the cloud logging, cloud tracing that you can get.
Yeah.
And then if you deploy it on the agent engine, which is a fully managed service, you would see everything. You would get everything that you saw on that ADK what you get slide automatically, right? So you can build an agent and just import the agent and just deploy it.
So the open
On the agent,
telemetry
right?
it just sends back to Google Cloud Trace. I don't
Yes.
have to.
Google
I don't have
Cloud.
to think about it. It's just there as part of the ADK.
Exactly.
Implementation.
Right. So, quick thing, you can have your agentic development lifecycle. Here's an example. Start with a design. You develop, you kind of evaluate, and then you kind of deploy, and then have your evaluation done, the testing done. You have your test cases, and then run it through your system, see what the expected output is, and do your report, and keep on iterating on this, right? And then look at this deployment here. You have a model there. So there is a model garden with with Google Cloud, and the model garden gives you first party, second party, third party tools that you could use, third party models that you could use with one click. Okay, so you could just click on that model and you could deploy it in Google Cloud, and you have an endpoint and you can use that model. Okay, so you have the option of using AI Studio for prototyping, and you can self-host it. Okay, through GKE or GCE, and that's your model. Okay, and now the agent is using a model, and agent is your code, right? You build that code. Every multi-agent system that you're building is kind of a AI application. Think of this as microservices 2.0, right? So all the 12-factor things that you can think of, and all the scaling that you would do with your microservices and how you would manage it, all that applies, right? So as an application, you could take this agent and deploy it on GKE. That basically says that instead of services, you're looking at agents, right? Then you have all your libraries, and use your ADK libraries. You have the MCP A2A and all the libraries that you can use. And then once you have this application, you can containerize this application. You can use Google Cloud Build, and then you could give it a Docker file, use the Cloud Build, and then you have a container image, put it in the artifact repository, and then you basically have that container run. Um, you can run it as a Cloud Run, you can run it on GKE, you can run it as a Cloud Function, or you can bring your agent and run it on the agent engine. And the runner that we talked about, you can invoke a Vertex runner. We saw how to define that when you are defining a runner instance, and then it runs on your agent engine. Okay, so this is how you deploy it. What happens when you deploy it in Google Cloud? You would get all the, especially when you deploy it on the agent engine, you would get all the goodies of your Google Cloud, which is, before I get to that, I'm going to show you how it will look in Google Cloud. You will get all the functionalities and all the capabilities in terms of security, in terms of safety, in terms of using the models when you deploy it on Google Cloud. Now I'm going to introduce you to the agent starter pack. Now, how do you deploy it in production? Now we have a collection of production-ready templates. This will definitely reduce the time to production from months to weeks. You definitely want to use the starter pack. Now you have your MVP. You are close enough to go to the path to production. You start using the starter pack and get it ready for your production, right? So it gives you a lot of things. It gives you a production-ready API server with a real-time chat interface, event streaming, and auto-generated docs. You have a playground for experimentation. You have CI/CD and Terraform for quick deployment, including a set of integration and load tests that you could do. You can use ready-to-use AI patterns, diverse set of examples, conversational, chain, custom RAG, LangGraph agent, and whatnot, right? And then you have the GCP native observability. This is where you ask for how do I debug, how do I log, how do I trace. Now, this is where Google Cloud Tracing and logging comes in, and it also includes a pre-built Looker dashboard for monitoring. Okay, so on the right-hand side, look at that picture. Might it be the evaluation, might it be the LLMs, might be data, observability. You get all that with the starter pack. Okay, so use your starter pack and then do your path to production, right? And here's how it'll look in the Google Cloud, right? So on the top is your application users. They are going to start with a prompt, and then you have your AI developers that are going to use the ADK, and then it all comes into Google Cloud, and the system is deployed within a specific Google Cloud region for low latency, and then you have Cloud Run Services that manages the user interaction. That is your front end here. That is also your human in the loop interaction that you have there. And then you come to your agent. In this case, we wanted to use a coordinator pattern, right? So you have your coordinator agent. Now, Vertex AI hosts the model, providing high availability and inference requests. And you would see that, your agent here has sub-agent invocation, and then it can do a bunch of tasks, and then you can do iterative refinement here, and then you have your response generator, and then you get your response. And this is the green box is your agent box, right? Now, when it comes to the agent runtime, you could use the Cloud Run, or you could use the agent engine, or you could use GKE. So depending on what you use, agent engine is, as I said, it is managed by Google, and you could bring your agents and just deploy the agents on the agent engine, right? If you're doing GKE, it is kind of bringing the application to GKE. There are a lot of things that you're going to do, just like what you would do for the microservices, right? And then you have tools and database within the system that are secured and managed. So you see the MCP clients here, and your agents are interacting with the MCP servers, and you have your tools within the Google Cloud. You see your databases and the APIs that you have. And then you can also have your MCP clients reach out to external tools. That's where you have your external MCP servers. And then you see your model armor coming in, DDoS protection, and then you have your AI model, which is your Gemini. And then we talked about the models that can run on, that's your model runtime, can run on Vertex AI, Cloud Run, or GKE, as with your agents that are running. Okay, so that's how it looks like. So in our customer refund, the customer refund starts at a Cloud Run front end. This is where it's going to start. And then you have a coordinator agent that will manage the core logic and agent orchestration. Then you have specialized sub agents that is going to execute the task and necessary internal tools. And then you have the AI models such as Gemini, which is hosted, which runs on Vertex AI. And then agents are deployed to our Google Cloud Platform via Cloud Run or Agent Engine or GKE. So that's how you bring your MVP to prod. Okay. And this is the last slide in the presentation, and I'm going to give you a couple of takeaways. Now, autonomous agentic systems, when you build autonomous agentic systems, these are a couple of things that you have to keep in mind, right? So agents versus autonomous agents, right? Agents act, they have a goal, they act. Autonomous agents adapt and decide, right? Now, somebody asked, like, can I make it more deterministic? We are getting to a place where software is going to run software. Software is going to build software. Software is going to operate software. Now, as with any tool that you saw, might it be the AI Studio that you saw, or might it be the Gemini.google.com, the Gemini app that you see, or might it be any model that you're using? There is already autonomous cycle that is going on, right? So I ask it to build a system and then assume a couple of things fail, and they basically analyze what failed, and then they will apply the fixes, and then they will go back and recreate it. And this cycle continues, and you can define where you want to stop, right? Try it 5 times. Human in the loop, you can add a human in the loop. So you want to be cautious of how you are controlling that part, and how autonomous you are making it, and how you make your system successful, right? So there are a couple of core challenges. So planning the plan. So usually what I've seen is, like, you give something to LLM and it shows a plan. I don't know how many of us really go in and see if it is the right plan. And there is a human verification that can be done, right? So how good the plan is, how would you reason? You can modify the plan. You can do a lot of things with the plan, and then have that plan get executed, right? Planning is key, and sometimes you have a lot of challenges as to can I automatically generate this plan using another autonomous agent, right? So I can go into a loop in this planning cycle, right? And then, of course, there are memory wars, and then critic cadence. So if you are having a critic model and you're saying, like, I'm generating something and I have a critic, now how would you have this critic go in a loop, and how would you decide when you would break, right? And then the tool strategies, how many tools you use, how you connect to these tools, and what tools are best for you. And then, of course, you have this debugging chaos, right? Something happens when you deploy this multi-agent system and you have hundreds or thousands of agents working together to do something, and something fails, and you go into this debugging mode to see, like, where it failed and how it failed, right? And of course, you're building autonomous systems, so the first answer would be, like, let me build an agent which will go and automatically debug this, right? So evaluation is key. Don't just measure if it works, right? Measure how well it works. What is the success rate? What is the coherence, the cost, the robustness, right? Definitely evaluate before taking anything to production, especially with autonomous systems, right? Now the design patterns are emerging. So what you hear today is a snapshot in time. So all the concepts might stay, the tools, the capabilities, and with the patterns and the interaction models, all that is evolving and is changing um, pretty fast, right? So as an example, the deep agent from LangChain, and then you have agent swarms, right? So think about all the emerging patterns and see if you could make use of those patterns, right? And then you have a mind shift here, right? Building agents is not about coding bots. It is about architecting mini organisms. They have life, they're going to evolve, they're going to change, they're going to behave and adapt, right? So think of them as building um, architecting mini organisms, right? And the final thought: today's agent may stumble, but tomorrow's agent will collaborate like human teams. Your design choices will shape that future. So I want all of you to remember this quote: civilization advances by extending the number of operations we can perform without thinking about them. So let us build some cool autonomous multi-agent systems in Google Cloud, and then we will keep advancing our civilization. Happy building, everyone.
All right, now on to some questions. I think we're going to skip the networking part for today, just because there's so many questions and so if you have time to stick around and hear some of the questions and answers, we'll try and get through these. Maybe do another 10 minutes and then call it a night. It's been great. We'll get the recording, the slides, the I think the GitHub was already shared up there. So I'm just going to scroll back in time, and then there'll be one Bala. I ask a non-technical question, so there'll be one coming up for you that I ask everybody. All right. Thomas was wondering if there's a way to set hard boundaries for specific values. For instance, if someone manipulated the agent to refund 10 times the original purchase amount, is that there are ways to make sure agents not overdoing it or giving away Ford F-150s for free?
So we have that check, right? So as soon as the request comes in, there's going to be a check for eligibility, right? So one of the things I did not show, if you take that code and ask for a refund, if David goes and asks for a refund again or a credit again, it is going to say like, hey, it's already processed. I'm not going to give you a refund, right? So this is standard business process, standard way how you think about things, right? So you can give all this as instructions to the agent and have the agent do this automatically and basically say that uh, validate if this request is coming again and again and if it is already satisfied, right? So this is where you would all the context becomes very important, and your short-term and long-term memory and what you did becomes important, right? So definitely you can define the guardrails, you can define how the process works, and you can also give detailed instructions to your agents and a playbook on how they should behave.
All right, and let's see, scrolling back in time. Yeah, we'll make sure to kill that API key so won't have to fuzz it in the recording. Do you have any good rubric or rule of thumb on when we're back on the different agent patterns, where they have parallel agents and sequential agents? Any thoughts on when to use one versus the other?
Definitely, there are a lot of recommendations on what to use, when to use, and how to use it, right? Um, in the interest of time, it is all in the documentation. Take a look at when to use what from a um, you know from a pattern perspective. Most of the times, what I have seen in the real world when it comes to enterprise applications, it is not one or the other. So you would look at those levers in terms of what is the flexibility I have, what is the control I have, what are some of my non-functional requirements, and then you would basically bring them together, right? So uh, depending on how you define your flow and how you define your interaction model, you would pick what you need for your task and what you need for your goal, right? So, for example, we talked about parallel patterns. So,
Yep.
if you are picking a process where you can execute multiple things in parallel, then you would use a parallel pattern, right? So, if there is something that has to wait for the input of the other, it cannot proceed without the input from the other or the outcome from the other agent. Then you got to think through and you got to use a sequential pattern, right? Um, the simplest, of course, one agent does it all. Of course, you can use it for most of the things, but that's going to be pretty I would say, even though it is simple, it's not going to satisfy your use case, depending on what you're doing with your business process.
All right, so then there's deeper recommendations inside the, dig deep into the documentation. There's like,
Yep.
uh, uh, better, not better, deeper choice models there. On our multi-agent system, each one is making calls to the underlying LLM using tokens, making API calls.
Yep.
Is there a way to? We did see that there is like tracing that shows us performance metrics. Do we also get the token usage per agent, so we can maybe one's overusing tokens?
Yeah, the dashboard that I showed briefly,
Yeah.
it has most of this stuff.
Okay. So each agent, I'm assuming, has its own identity
Yes.
and its
Yes.
own. Would I want to be sharing my API?
What
key?
API calls are coming in, and how many calls are made, and how many tokens input and output, and what are some of the limits and quotas that you have, and how you measure up against that. So all that is in the dashboard.
And will I want each of those agents to have their own API key? Question mark.
Yes, you can. It is all how you weave it in, right?
Okay.
So the idea is when you are building a multi-agent system, you are still going to follow all the best practices when it comes to defining your projects. You will have a host projects, shared project, and all the stuff, good stuff that you do with Google Cloud when you are deploying a scalable application, right?
Let's see. We're scrolling back up through the chats. Sam asked, based on the key aspects to consider, and I forget what slide that was on, we must employ multiple architectures simultaneously to address various scenarios. Is that right? I mean, I guess there's not one. Maybe to say it another way, there's not one answer for. There's not one answer for every business problem, and in fact, there's probably multiple. There's probably multiple ways to get something.
Absolutely, yeah. That's your trade-offs, right? So you got to think through your trade-offs, and you got to pick the design. So anything that you learned in terms of architecture concepts and how you build systems and how you put systems together, that does not change, right? So yes, there are so many ways that you could build the system. And we talked about two interaction models, right? We talked about coordinated and we talked about competitive, right? So if you think about the competitive one, it is basically saying that it is going to kind of create competing solutions, right? And then you're going to have an evaluator evaluate all these solutions and pick the right one. In that model, you're going to see multiple solutions come out for the same problem.
Right. All right. Scrolling back up through the screens here. One, thinking about our this might be on a control agent. So maybe I have my individual agent. Maybe is there ways to set up for that individual agent multiple LLMs that it could call, and it determines which one it wants to call, either based on maybe that one's performing poorly and now I need to switch to a different one, or the latency is bad at one LLM endpoint, I need to switch to another one. Is there some kind of multi LLM switching I can do inside the individual agent? Have you seen that?
I have not seen that. The only way is there is a place where you define your model, right? So when we define an agent, we define what the model is. If you remember, I showed you that we used Gemini Flash, right? So that is a place you can switch the models to see how it performs, right? So of course you could automate it, and of course you can have Google Code Assist do that for you, right? Change different models and re-execute to see like how it performs, capture some metrics, and see how you could evaluate it, right? But I've not seen where you give multiple models and have the LLM reason what model it should pick. I've not seen a definition inside of ADK like that.
Okay. All right, maybe, I don't think I'm gonna get to all the ones up the top. I'm gonna do one final question, Bala. This is one non-technical. And we get, it's a career question. We get, usually our speakers are, well-seasoned tech professionals. And we get, sometimes we get some younger people that join, and just wondering if, what do you, knowing what you know now, any kind of advice that you would have given a young Bala or a young person kind of entering into the technology field, or just entering into a career in general? What kind of, any tidbits or sage words that you think could help them along the way?
I would say don't stop learning, right? So just between the time that you put this session together and delivering it, there is so much that has happened, right? We are accelerating at a very rapid pace. Everyone has the quest to this AGI, and everyone has this quest to make the whole AI industry boom, right? So don't stop learning. That is the biggest thing that I would say, right? Don't stop practicing what you learned. Be curious and do a lot of experimentation. What I've seen is that with all the prototyping tools and with all the code assists that you could get, and lot of open source repositories that are out there, there is so much that you could do, right? So be curious, experiment, read a lot, and keep learning and keep practicing. That's what I would do.
Perfect ending, Bala. Really appreciate it. You taking the time to run through the multi-agent system. It's like layer upon layer upon layer upon layer, but you made a clear presentation of that. Thank you, everybody, for joining us. Maybe we'll see you again at a future session. We'll start having our 2026 sessions show up on the calendar, so keep an eye out for more sessions in 2026. Once a month, usually the last Wednesday of the month. Some shifting here and there, and then once a month we'll have our in-person social clubs. So maybe we'll see you online in the future, or at one of our social clubs. Apologies for maybe not getting through all the questions tonight. There's a very dense topic. I'll definitely get the GitHub link from Bala, and maybe some additional learning links if you want to try it out. Maybe have some of those embedded in his back pocket, so you can go keep practicing, keep building, and really, Bala, thank you again. It was great.
Thanks, everyone.